All right, so today we're really focusing on key features. We're talking about like all of the identifying the parts, focusing really on axis of symmetry. That'll come up in just a second. So we got 100 feet of fencing. We want to build 3 different fences in the pasture that can use exactly 100 feet of fencing. Are we talking about area or perimeter? All right, convince me why. What is the formula for area? Length times width, right? What about perimeter? Okay, you add all the sides, right? So if we were doing our fencing, we would need to go all the way around, right? We would need to add up all sides. So are we doing area, perimeter? Perimeter, yeah? Okay, so take a second, build 3 different fences in the pasture that use exactly 100 feet of fencing. Okay? Right, let's check your work. All right, let's go. Okay, so Wen helped me with this one. Okay, he said 25, 25, 30, 20, 20, 30. All of those would work. Good. Okay, looking at slide number 2, how are they similar? How are they different? How are they similar? How are they different? Okay. Well, the first thing that we notice is that they all add up to 100, right? But some of them are skinnier than others. Okay. I wouldn't want to put my sheep in something like this. What do you think? That would be tragic. You would have like all of them like super squished and they'd be like, they could only walk in like a circle, right? Okay. On slide number 3, calculate the area. You told me the area was what? Area is length times width. Okay, so go ahead and multiply these and fill in this table. All right, looking at your answers. David helped me out on this one. He said 625, 525, and 525. Ta-da! Okay. On slide number 4, it says complete the missing values. What do you notice is happening with these lengths? What do you see that's happening with these lengths? Are they increasing or decreasing? Lengths. The middle column. Decreasing by what? 5. So this guy's going to be 20. And then looking at the widths, what are they increasing by? 5. So we got 25, and then we got 30, and then we got 35. Yeah. Oh, nope, JK. JK. JK again. 40. Okay, 40. And then 45. Can you fill in the areas now? So what do you notice about this? So what you could notice about this is that my maximum area is right here, this 625. But let's like think about that real quick. So look at the width and the length. It's 25, 25. That's a square, right? Okay, a square maximizes my area. Do we see that? Because it makes it the biggest. I would think that like one of the side lengths would need to be like something real big in order to make a big area, right? But no, when they're the same, if they're close to each other, that maximizes your area. Fun fact. Y'all are staring at me like I'm crazy. Great. Okay, take a moment. What type of function is this guy? What have we been talking about? It's a U shape. What is it called? Quadratics. Fantastic. Okay. U shape. There's a U in quadratics. Okay. All right. So looking at slide number 6, parabolas have a line of symmetry. That means that they're broken into even parts. So you could take it and you could fold it, right? So I want you to move this little line over here to where you think the axis of symmetry is. Take a second, try it. And then what does this line mean in context of the sheep fence? Once you figure it out, okay. So you should have gotten it equals 25, right? Yes. Axis of symmetry equals 25. This is going to be on your SAT. They always ask this question. Don't know why, but they do. Okay. Now, what does it mean? Well, it means that the width is going to be 25 and the area is going to be 625, right? Okay, we're maximizing that. Go ahead and take a moment. And on slide 7, his sheep do not, or her sheep, I don't know who this is. Sheep do not like to swim. If she builds her fence by the stream, it will only need 3 sides. So when you're doing this, you've got length, width, etc. Add that together, that equals 100 feet. Okay, so go ahead and take a moment, see if you can fill those in. Okay. So here are a few possible fences that the farmer could have. Is this relationship a quadratic? How do we know? Okay. But it doesn't have like that other half of the U, right? Okay, so watch the magic. You ready? Yesterday we talked about first difference and second difference. If we found the first difference of all these things, this would give me 350, this would give me 250, this would give me 150, this would give me 50. These aren't the same, right? Okay, I need eyes on the board because I just wrote like a bunch of numbers on it. Okay, it's not linear then, since the first difference is not the same. If we find the second difference though, do you see how all of these are the same? That makes it quadratic. So even though I can't see the other half of this graph, and I assume that this is the maximum, but I could be wrong, then I can find it using the second difference. Now, I could mimic this on the other side because since this is the axis of symmetry, it's going to be equidistant. So it's going to be equidistant from the axis of symmetry. So you see how like there's this much space in between here and here, and this much space in between here and here. So it's the same amount of space in between. Do we see it? Okay, go ahead and move to slide 9. Okay, now you can fill this junk in. Okay, so when you're coming in here, this guy's a maximum. But what is this guy going to be? Well, this is going to be the same as 20. We're going to have 1200, and then you're going to go to the next one, and you're going to fill that in and be 1050. And then the next one, whatever that is. Okay. Take a moment, try that. Okay. Now on slide 10, it asks you for the axis of symmetry. Where's this axis of symmetry? Where's the middle? Where's the middle? 25. So here's how you write axis of symmetry equations. Because you're going to be asked this, and everybody always asks me, what do you mean? Write the equation. X equals 25. When you write x equals some number, that draws a vertical line. X equals some number. That's the axis of symmetry. Okay. Go ahead and skip to go ahead and go to skip to slide 13. Go ahead and complete by a burst of compressed air. So press try it and see what a stomp rocket launch does, and then discuss with a partner what you notice, what you wonder. So it goes up, and then it goes back down. Okay. So discuss with a partner what you notice, what you wonder. Take a second. Do that. Okay, so make a prediction. How high do you think the rocket will be after 4 and 5 seconds? How high do you think the rocket will be after 4 and 5 seconds? Okay. So looking at slide number 3, we talked about this earlier. Remember, first difference, second difference. Describe what you did to find heights at 4 and 5 seconds. So, like, summarize what's going on here. So, on the next one, how high will the rocket go? How many seconds did it take for the rocket to touch the ground? This one, I want us to talk about. So we're on slide 5. Okay. So if we find the first difference, so the difference between here and here is 45. The difference between here is 35. The next one would be 25. So what's 80 plus 25? 105. Please don't tell me I'm talking to myself today. All right, the next one is 15. So we're going to add 105 plus 15, and that's going to give us 120. That's at 4 seconds. The next one will be 5. So it's going to be 125. And then the next one's going to be -5. So it'll be 120. And if we continue that on, we'll go all the way to 10 seconds. So how long will it take for the rocket to touch the ground? It'll be 10 seconds. The reason why I know it's 10 is because 5 is our maximum. We see that we hit a point and then we start going back down, right? Okay. The stunned silence is very reassuring. Okay. On number 6, go ahead and take a moment to try this one. Try this one. All right. So some of y'all said 6, some of y'all said 8. The correct answer is between 6 and 7. I only had 2 people get it right. Shameful. Okay. So when you do this, you're finding the first difference and then you're finding the second difference. Okay. All right. On slide number 7. Nope, actually, we're going to skip that one. Go all the way to slide 11. Go and go to slide 11. See if you can answer these 2 questions. Now, the table and the graph are the exact same thing. Okay. All right. So how high was the rocket after 5 seconds? So one thing to keep in mind when you're doing these, if they only give you a table that's not completely filled in, then what you can see is that at 3, it's 240, right? So that means that over here at 5, it's also going to be 240. So it should have been 240 for 5 seconds. And then how long was it to take it to hit the ground? Well, that's 8 seconds, right? Where it landed. Okay. Anybody okay on that? Okay. So on your paper, you should have had A, D, G, L, and M all in disagree. The rest were in agree. So again, A, D as in dog, G as in goat, L, M as in monkey. The rest of them are all agree. Are there any that you would like for me to go over? Okay. So just a reminder, your interim is on Wednesday, February 7th. Okay. Tomorrow, I'm going to ask you to basically work on that interim packet. You picked it up just at the beginning. If you didn't get one, you need to make sure that you get one before you leave. Okay. So the interim is on February 7th. Okay. So tomorrow, you're going to get a little bit of practice on Delta Math and your interim review. That's what you'll be working on. Okay. Are there any questions? Okay, if you need to make up a test or a quiz or whatever, you need to make sure that you come see me after school. We got to get that grade caught up.